Okay, so to understand patch plots, we first need to look a little bit back at system diagrams. So here is a system diagram for a little show I did a while back. And, you know, this is fine. It's a simple little diagram, not a whole lot going on. It's an easy system. But if I were to try to put this system together, like if I was going to build this in real life, there's some information that I would want that is not contained in here. For example, how many XLR cables am I going to need to put this system together? I don't know. This drawing doesn't really give me enough information to know that. I could guess, but guessing is dangerous, especially when your equipment is in a different building than your theater. You don't want to guess. So that's sort of the first problem with the system diagram. Now, you could go in and label all of these different connection points with connector types, and then you would know. And you guys are learning connector types right now in ITP. So, you know, that's going to be fun for you. So this drawing doesn't have that. Here's the thing about connectors and cables. If something isn't working or something breaks in your system, I think most of the time it's because you have a problem with a cable or a connector. You know, a cable got cut or broken, or a connector came loose or got unplugged. That's usually what happens. That is assuming that you have hooked everything up the way you had planned, right? That would be the other thing, is maybe you just didn't do it the way that you had planned to do it. And it's not usually that the equipment breaks. Okay, I think that especially when folks are just starting out, we're really quick to blame the equipment, right? We're able to say, oh, this thing is broken, it's not working. And generally speaking, we're getting pretty good at making sound equipment now. 20, 30 years ago, we weren't as good at it, and things were a lot more fragile. But nowadays, all the components are solid state. You know, everything's digital, and the stuff doesn't break as easily. I mean, power supplies blow up from time to time, but generally speaking, the equipment doesn't break as easily as it used to. So if something's not working, it's usually because it's just not connected right. So you need to have some way of knowing where all those connectors are. So if the connectors and cables are the things that are most likely to cause you a problem, it's really important that you know where they all are, okay? Because if suddenly you're not getting sound out of something, for example, let's say I'm suddenly not getting sound out of my two front fills here. And I used to have sound out of them. It's most likely because of a cable or a connector that has gone bad or got disconnected or something. And I'm not going to be able to solve that problem unless I know in the physical theater where all of the cables and connectors are that are part of the signal chain that feeds those front fills. So what a patch plot does is it helps you identify all of those cables and connectors so you know where they all are and how they all connect into your system. The other thing it does is it helps you figure out how many of different kinds of cables you need when you're pulling equipment for your system. So, the patch plots accomplish two things. Helps you figure out how much cable you need to pull, and then it helps you troubleshoot your system when it's not working. Now, this particular diagram definitely falls into the category of Jason Romney insanity paperwork that, you know, you are probably never going to do out in the big wide world because it takes too long and no one's going to pay you for that time, and you know you're going to get good at figuring this out without having to do the paperwork. Again, the point of the patch plot is for you to demonstrate to me that you have thought about all the things that you need to have thought about in order to put this system together and to troubleshoot it effectively. So I'm going to show this to you, and you're going to think in your mind, he has gone insane. I can't believe that he actually expects that we're going to make this complicated of a drawing. And it's like, yeah, okay. Well, first of all, yes, I am going to ask you to do it, but I also acknowledge that it is insane. Okay, but it is important because it helps you to demonstrate to me that you've thought about all the things that you need to think about. So, sorry, not sorry. This is going to be a doozy, all right? So let me show you what I mean by a patch plot. So here is that same sound system documented as a patch plot, okay? And I'll do it in this view. So what I've done is I've created a spreadsheet. And this spreadsheet shows me every single connector that is in this entire system, okay? And you see there are a lot of them. So like every spot that you see, let me zoom in here a little bit. So every place that you see like XLR-M or XLR-F, those are XLR connectors. So remember I said that connectors are the things that are going to cause you the most problems? When you draw it out like this, you see just how many of them you have. There are an awful lot of connectors in this system. So it's sort of ironic that the thing that is going to break the easiest just happens to be the thing you have the most of in sound, and which is what makes our life so stressful when we go into a tech like this, because we have these things that the equipment is pretty solid now, but the connectors are still really not, and they break all the time, and we have just a million of them. Even in a simple system like this, I mean, there are hundreds of connectors in this system. And just one of them going wrong could disable all or some significant part of my sound system if just one of these connectors goes bad. And how am I going to know which one goes bad if I haven't figured out which ones exist in the first place? So that is the point of this drawing, is to figure out where all the connectors are, what they are, so that when one of them breaks, you have a fighting chance of finding it, okay? So the basic idea here is, where the system diagram is really sort of broad strokes, simple overview of how the system goes together. There's not a lot of detail here. It's just generally, here's how one thing feeds into the next thing, feeds into the next thing, and here's how things split out. Really small amount of detail. The patch plot is the complete opposite of that. So there is no such thing as too much detail in a patch plot. And whereas the system diagram is relatively easy to read, you can glance at this and get a really easy sense of like how the system goes together. The patch plot, this is not the diagram you're going to use to figure out how the system works. Right? You're going to look at this and go, too much information. This is going to help you when you have a problem. And what I mean by that is, like, let's go through my scenario where I said those two front fills went out. So here they are. It's this one and this one. Okay. So let's say they both went out. I lost signal on them. So I go here to the patch plot and I say, okay, well, if both of them go out, then whatever went wrong happened before the first one, because the second one is daisy-chained off the first one. So the problem is somewhere before the first one. So I would start by saying, okay, well, what's the first connector that I encounter if I start walking backwards? And it's like, oh, it's this one. It's this NL4 that plugs into that first front fill. So that's the first thing I'm going to check. I'm going to go check that connector. I'll open it up, unscrew the little strain relief, look at it, see if the wires are still connected. If they are, great, I'll put it back together. The next connector in this signal chain is this one. and this one is plugging into the wall. So the purple cell means this is a wall plate. So I'm going to take this part of the connector, that cable that plugs into the wall. I'll take that one apart. Look and see. Okay, is everything still connected? All the wires in place? Okay, good, they are. Great. The next one is the wall. Can I look inside this connector on the wall and see if it's broken? It's probably not. If it's sitting inside a conduit and not moving, it's probably not going to break. So I might wait on that one. And I would just keep going up until, okay, where's the next connector that is likely to have broken? Okay, here's a patch cable. That's one that moves around a lot. Connectors tend to break when you move them. So I would look in this one and see, and I would just keep kind of going backwards through this, through each connector that is movable until I find the one that is broken. And eventually I would find one that is messed up. And then I could fix it, and then I would have sound again. So now trying to do that with your system diagram is going to be a little tricky, right? You're going to have to guess on a lot of things, because you could go in here and you can figure out, oh, they're daisy chained, but trying to figure out where all the connectors are. For example, in my system diagram here, I have not diagrammed the fact that there is a wall plate connection here between the amplifier and the front fill. In fact, there is a wall plate connection and a patch cable in real life, and that is not documented in my system diagram. So if all I had was the system diagram and this was the level of detail I had, I would not have any idea that this problem existed if it was one of these cables that went bad. So, yes, Kelsey, this particular format of the patch plot is something I came up with. It's not an original idea. I mean, the concept of a patch plot is not a Jason Romney invention. Lots of people do patch plots. They do them slightly different ways. This is just the way that I've come up with that makes some sense. It's a lot of detail to try to think through, and again, it takes a long time, and it's not something that I think you're probably going to do a whole lot of in real life, just because it's a lot. But you know, in real life on shows that I will do like little small patch plots. Like if there's a section where I've got a whole patch bay and I'm going to patch a whole bunch of cables together, yeah, I'll plot that out and figure that out on paper, and then I'll hand it to somebody to do. I won't necessarily do the whole system, mostly just because I'm usually not, in the shows that I do personally, I'm usually not the one putting the system together. Someone else is doing that, and they're usually professionals who know what they're doing, and you know, I don't need to give them this amount of detail. They'll figure that out. They'll figure out what cables they need. I don't need to tell them that. But if I was the engineer that had to figure this out, then I might do some of this detail. All right, so I'm going to take you through making one of these now. So you're going to do this in a spreadsheet application. I prefer Excel over something like Google Sheets, for example. I mean, you can use Google Sheets if you want to. The problem with Google Sheets is it doesn't have as much flexibility in when you get to the part where you would have to lay this out on a page. Because Google Spreadsheets is really, it's meant to be like a web app. When it gets to the time of, like, okay, how do I make a PDF out of this or something and make it look nice on there, it doesn't have as much flexibility as something like Excel does. It can do it, it's just a little, requires a lot of extra steps that aren't necessary to make it work. There's another one that you might be familiar with called Numbers on your Mac. Numbers is sort of like the opposite of Google Sheets, where Numbers is really good at making stuff look nice on paper. But in order to do that, I think it sacrifices a little bit of flexibility when you're creating it, right? Because it sort of locks you into layouts to begin with, which I don't really like that. So I would recommend doing this in Excel, but ultimately I don't really care. You can do it in whichever one you're comfortable with, just as long as it follows the rules that I'm about to give you. All right, so I'm going to start with a new spreadsheet here. Let me zoom it in so you can see it a little bit better. So the first thing you would do if you were going to make one of these is, let me go to my system diagram here. And I'm going to start with this mixing console. That's usually where I start just because everything kind of connects to that one way or the other. So I start there and I work my way out. So I've got a mixing console. It's a Yamaha LS932. So let me just go ahead and make that. I'm going to start here. And I'm going to say Yamaha LS932 mixing console. All right. Now that mixing console has connectors on it, right? That's how the different pieces of equipment interface with it, is through connectors. So let's take a look here and see what we're dealing with here. So I've got some things patched to inputs. I've got some things patched to outputs. So let's work on some of these inputs here. So I've got, well, the first thing you need to know is that your patch plot does not have to follow the exact same layout as your system diagram. Okay? Something that makes sense in the system diagram doesn't necessarily make sense in the patch plot. And what I mean by that is, like here I've ordered things with 27 through 32 first, and then here I go from 14 to 26, and then number 1 is here. That might make sense in your patch plot, but maybe it doesn't. Maybe it doesn't have to, you don't have to do everything in the same order, okay? So don't feel like that the patch plot is really just a spreadsheet version of your system diagram. It's not. It doesn't have to look the same way. Things don't have to be in the same order. This is all about just how one thing connects to another thing. So maybe I'll start, just because it'll make things easy, with this audio interface, okay? So the audio interface is the thing that the QLab computer has that has the audio outputs that plug into things. So, and I'm going into Omni, or input 1 on the Yamaha LS9. Now I happen to know, because I looked at the LS9, which you should do this when you're making these for real, is actually go look at the equipment, or at least go look at a picture of it, to figure out what kind of connector it uses. Now, I happen to know that the Yamaha LS9 uses XLR connectors on the inputs. So this is going to be an XLR female connector, okay? XLRF. And it has a label on it. What label is it? Input 1, okay? So here's what I'm going to do. I'm going to move that there and put the input 1 here. So the idea is, there's the connector. The connector has a label on it, and that label is screen printed onto the mixing console. All right? So I also then have, well, let me make some other stuff here before I get into this. So let me do let me do this. Let me do this 14 through 26, which is this sort of snake, this stage box snake. So that's going to be some XLRs, 14 through 26. So I'm going to do input 14, and that's going to be an XLR F as well. Now, let me teach you a little shortcut. Everybody watching? This is going to make your life a lot easier. It was 14 through what? 26. So I could go in and I could just like type all those out, or I could let Excel do some of this work for me. If I hover over this little dot handle on this selection, I select those two, I hover over this, and you see how my crosshairs turn, they start out white and now they go black, see that? So if I click and drag now, look what happens, see how it's incrementing? So it's 14 through 26, right? Is that what I said? Yes. Look at that. It incremented all those numbers for me. I don't have to type them again. I just drug it and it incremented them. Now, it did not change the XLRF because that wasn't a number. It just copies that down. So I didn't have to do anything there. Saves a ton of time. Okay. then I also have my wireless mics on inputs 27 through 32. So great. So that picks up right where that left off. So I can go to 27 to 32. There you go. I've got all my inputs done now. So what I'm going to do is take this cell that represents the mixing console, and I'm going to select all of the cells underneath of it that line up with these other connections and inputs. And I'm going to click this button that says Merge and Center. Very important. So you click that, and it makes that all into one cell. And then you want to position the text. So here you have your positioning. So this is sort of justification horizontally. Right now it's centered. This is vertical positioning. And right now it's set to bottom align. I'm going to make it middle align. And then it puts that there. And then the other thing I'm going to do is, you see how it's getting kind of chopped off there? So I'm going to click this button that says Wrap Text. And now it'll wrap all that, and I can see that all in one thing. Okay, let's look at the outputs here. So I've got an output 1 and 2. So I happen to know, because I went and looked at the console, that on the back of the Yamaha LS9, these are labeled Omni. Omni 1 and Omni 2. So I'm going to call it that. Omni 1, Omni 2. And let's see what else I have. Oh, those ones don't have labels. That one has a label. And it's 2. I've got some errors here in my system diagram. So let's say that they were 3, 4, 5, and 6. And then these would be XLR-M connectors. I'll copy those in. There we go. So there's my mixing console. It's basically done now. So there's some color coding that I want you to do on these just to make this a little bit easier to read, because if you didn't use color, this would just be impossible to make any sense out of. The color helps break things up. So if it is a piece of equipment, and a piece of equipment is like something that you could put in a rack, or like a mixing console, or a microphone, or just like equipment. It's not a cable, it's not a patch panel, it's not a connector, it's a piece of equipment. I would like those to be shaded gray, okay? So to do that, you're going to go up here to this little paint bucket thing, this fill color, and right now if I hit this, it's going to go yellow, but I don't want it to be yellow. I want it to be gray, so I'm going to go here and pick a gray color. All right, see that? And you want not only the equipment itself to be gray, but you want all of the parts of it to be gray, which means the connectors and labels that are part of that piece of equipment should also be filled in that same color, because they are physically part of it. These XLR connectors are bolted to the mixing console. They cannot be separated without taking it apart and using tools, okay? So it's all part of one thing. The other thing I would like to do is just make the label of the thing bold. I think that makes it look a little bit nicer. And then you can also manipulate the width here, just to make, figure out something that looks nice. Another little trick is, you see how I've got all this space here after XLRF? That's space that I don't need. If I double click, if I go up here to the top of that column and double click on that little line between it, it will collapse it to fit. And I'll just do that on all of these here. And then the last thing I'll do is I'm going to turn on the grid lines for this. So I'll select all this, and then over here I'm going to say, show me all the borders. And that, I think, makes it look quite a bit nicer. Okay? That makes sense? Anybody got any questions so far? Does the font and font size matter? It doesn't matter as much here as it does in AutoCAD. The only time it would matter is if you start messing around with it too much, and then when you get to laying it out, that could be a problem. Generally, I would just like use the same font size for everything. Okay, so whatever you're going to use, just keep it consistent. All right, so let's work our way backwards now and figure out what would go into all this stuff. So on input 1, based on my diagram here, input 1 comes from this audio interface. Okay, now you don't know this, but I know this because I know which interface I used. And the interface I used had a 1/4 inch connection on the output, okay? So I'm going to need some extra cells here, right? Because I'm going to run out. So if I just select this column here and then right-click on it, I can say Insert and just keep inserting until I get a bunch more in here. So I'll work my way back here. What sort of connector do you think is going to plug into this XLR-F connector on the mixing console? Any ideas?
An XLRM connector.
Good guess, right? Yeah, that's actually the only connector that would be able to plug into that is an XLRM. So I don't even have to look it up. I know it's going to have to be an XLRM. So if I ever see you say, oh, an XLRF is going to plug into an XLRF, I'm going to say, no, it doesn't. You're just copying and pasting stuff and not actually thinking through this. Okay? So don't do that. All right. That XLR-M connector is going to be attached to something. What is it going to be attached to? Anybody? It's going to be attached to a cable. Well, just a cable, right? So any kind of, whatever kind of cable it's going to be, which you'll learn more about that from David here in a couple weeks. But yeah, it'll be a cable, right? There's a cable involved, okay? Now on the other end of that cable is going to be another connector. In this case, it's going to be a 1/4 inch TRS connector, tip ring sleeve. Now, if you want, you could call this a TRS-M or a TRS plug. But a lot of times, usually that's implied. You don't see a whole lot of TRS jacks that are attached to cables. It's usually the plugs that are attached to the cables and the jacks are attached to the equipment, right? So the plug goes into the jack, right? So I don't know that specifying that is super important here, but again, I said no amount of detail is too much detail on a patch plot. So if you ever find yourself asking the question of, should I include that amount of detail? The answer is almost always yes with the patch plot. So I'm going to say, I could say TRS-M or I could say TRS plug, depending on your whatever sensibility makes the most sense to you. Now that is going to connect to a 1/4 inch TRS jack. And that 1/4 inch TRS jack is going to be bolted to a piece of equipment and have a label on it. And that label is 1. So this is going to be output 1. And output 1 is going to be for an audio interface of some variety that I'm not aware of because it didn't tell me on my system diagram, so I'd figure that out later. But for now, I'll just say audio interface. Now, this audio interface is a piece of equipment, so I'm going to shade that in black, turn on my grid lines, make that bold. And now I've got this cable in the middle. Now here's the thing with cable. If it is a cable that you could pick it up, coil it up, and walk out of the building with it, then you want to make the cable label red. So you're going to do, instead of fill color, you're going to do font color. Make that red and bold. Why? Because that cable is a cable that you have to bring with you. If you could coil it up and leave the building with it, that means you have to coil it up and enter the building with it in order for it to be there. Okay? So you want to make those ones bold and red. so that when you finish this whole thing, you count up all the things that are red and you know those are cables that you have to bring with you. So if I skip ahead here to my finished one, I can see all these things that are in red and I can say, oh, I need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 XLR cables for my pit mics, so on and so forth. You count them all up, all those red things, because those are ones that you have to bring with you. And I'll go ahead and turn on grid lines for that too. All right, how are we doing so far? Everybody following along? Making sense? And I'll go ahead and just collapse these to save some space. Okay, let's see what else we can do here. Well, just let me do this. Now that you see the general idea, let me take you through this finished one. How about that? So here's the finished one, the way you would normally do it. So I would work my way through all of this and get it all figured out. And a couple other color coding things. So you see how this stuff is yellow? Yellow means it's a snake. And what a snake is a bunch of individual cables that are shrinked together into one cable. So it's a big, thick cable that has lots of cables inside of it. Okay, we call it a snake. So if it's a snake, you want that to be yellow, just so you can tell the difference between the snakes and the individual cables. If it is a wall plate, so let me find a wall plate here. So, okay, so here's a wall plate. So a wall plate would be like a connector that's on the wall in the theater. So you're going to plug your loudspeaker into this NL4 connector that is on a wall, and presumably there's some wire inside the wall that goes back to an amp room somewhere where you can hook everything up. So if it's a wall plate, I want you to fill that in with some sort of light purple or lavender color. Don't go too saturated on this because otherwise you won't be able to read the text. But it needs to be some sort of purple. And I completely made up these colors. Okay? Totally made them up. There is no rule other than I said it should be lavender. But the important thing is that we all do it the same way. Because if you want to sort of like express yourself and pick different colors, I can understand, the motivation for that. But the problem is if everybody's wall plates are a different color in their patch plots, then it makes it really hard for us to read each other's drawings and know what things mean. Okay? So stick to the colors I'm giving you. Okay? So you can see that this wall plate has both a connector and a label. And those are separate cells. And I would make both of them that lavender color. And then this house wire, that means this is a cable or a wire that is inside the wall. This is not a cable that I could coil up and walk out of the building with because it's inside of the wall. Okay? So you need to acknowledge that it's there, but you don't make it red or anything because, you can't get to it. It's inside of the wall. All right. If it is a patch panel, and by a patch panel I mean, right? So here's a patch bay. We've talked about patch bays before in our system diagrams. Patch bays are where all those cables that are running through the walls that show up on wall plates, the other end of them all is in the same spot, right? It's in a little rack that has a whole bunch of rows and rows and rows of connectors in them. And you patch them together by, putting the cables together, little tiny patch cables, put them together. You may have experienced that in crew this year at some point. So if it is a patch bay, then I want that to be blue. So here's an example of a patch bay, or patch panel. So you can see I've got the patch cable, which is just an NL4 with a cable and an NL4. And then on either side of that, I've got a set of blue cells. And one blue cell has the connector, and the other blue cell has the label for that connector that's on the patch bay. So you're going to do that in some sort of light blue. Okay? I think those are all the colors. So here, now what I'm going to show you is how do you plate this thing. So when you make one in real life, it's going to look like this. You're just going to put it all together. It's going to be one enormous thing, and you'll never fit that on a piece of paper, right? If I just try to make it all fit on my screen, it looks ridiculous, right? So what you have to do is lay this out a little bit differently. So in Excel, what you're going to do is you're going to go to Page Setup and pick what size of page you want this to be. I'm going to make it be a landscape, and keep the scaling at 100% for now. And let's just see what happens. This is, I think it's probably defaulting to an 8.5 by 11. Okay, I don't know if you can see this. Let me see if I can zoom in. You see these? See how this has a dotted line there? So that dotted line is where the edge of the page would be if you just hit print. Okay, so it's going to automatically split this up into multiple pages. And every spot where you see one of these little dotted lines is where a new page begins. So what this is doing is this is giving you some idea of how this is going to break up in a page layout. What I'd like to do is I want to see if I can change the page size a little bit. I may have to do that here in the print view. So I'm going to change it to tabloid, which is your 11 by 17. There, and now see, look, where my first dotted line now shows up all the way over here. So what you're going to do is you're going to kind of say, all right, if that's the edge of my page, here's what I'm going to have to do. First of all, let me just fix my spacing here a little bit. So you see how some of my lines are kind of overlapping here. I'm going to use my little double-click trick and spread things out. Okay, you would kind of go through and do that. Then what you're going to do is you're going to take this sheet. See where it says Sheet 1 down here? You're going to right-click on that, and you're going to say Move or Copy. And you want to create a copy, and click OK. The reason for that is you're about to blow this whole thing up, and you want to be able to go back to the original if you really mess it up. Okay? So I kind of see how this is going. What I want to find is I want to find a spot where I could make a page break that would make some amount of sense. Okay? So I think I would want to break it here, where that snake is, because there's not a lot of detail going on there. So I'm going to start there, and I'm going to zoom out here, and I'm going to select everything after that. Okay? And then I'm going to hit Copy. And then I'm going to go down here and paste it. And then I'm going to come back up here, and I'm going to change my selection. So now I'm going to select the thing right after that snake and go and select everything after that. And I'm going to right-click on this and say Clear Contents. It went away. And then I'm going to go ahead and say No Fill and No Border. Just get rid of all my grid lines there as well. Hang on, my mouse is freaking out on me. All right, it's probably because I'm screen capturing. So you'd clear the borders out as well. Okay, so there we go. Now I want to. The reason I did it that way is I want to make sure that whatever the last cell was on my layout, I want to make sure that I repeat that when I go to my next line. Oops. There we go. So I know where to pick up again, right? So I'm going to now go to another line, and I know that I'm picking back up where I left off. Makes it a lot easier. Just repeat whatever that was and keep going. And then so you just keep doing that, keep finding a spot that's a logical place to break it up that fits inside your page layout, and look for that dotted line. So again, there's the dotted line based on my page size. So I would try to find the next logical place to break this up. And some of that's going to be affected by your cell width. For example, you see now that I put this down here, it's getting cut off. So I'm going to have to resize that column to fit that all in there. And as you start resizing this stuff, that page dotted line is going to move. So I would take this in small steps as you're doing this, so you don't make a change that then is going to be a problem for you. For example, like this is getting squished way too much. So I'm going to undo that, and that might mean that some of these ones on the top get spread out a little bit. That's okay. So that's the basic idea. So when you're done, you'll end up with something that looks kind of like this. And now this is something that I could plot or print. So I'm going to save this. Oh, the other thing I'll show you is put a thick line in between these. So I would go in here and select all the way across this. And under your borders here, do a bottom border, and have it be a really thick bottom border, which for some reason is not working for me right now. Again, I think it has something to do with my screen capture. All right, it'll work for you when you do it. If you have trouble, let me know. But you want to make that just a thick border like that, so it looks like this. So you see, you can tell because of that thick line that there's a separation here that I've dropped from here to there, right? And I've dropped from here to there. We keep going. So now what I would do is I would take this and I would select this whole area, and I would do File and select Print Area, and say Set Print Area. And that just tells Excel, this is the part of the spreadsheet I want to print. Okay? And then I'm going to go to File, and I'm going to actually try to print it. But what I'm going to do is save it as a PDF. Okay? So I'll save this as a PDF onto my desktop here. And now if I go over to CAD, I'm going to make myself a layout in CAD here. And I'm going to insert a PDF underlay. And I'm going to get this here, and I can put it here in Paperspace. My computer is really slowing down here because of all this screen capturing I'm doing. Yeah, Zoom is chewing up a ton. All right. Okay, I got it. So you could scale this a little bit once you get it in there, and then it would be in your layout. So Kelsey's asking, each segment doesn't have to be the same amount of cells. Right. So yeah, it would be lovely if every line ended in the same spot, but it's just not reasonable, right? And the reason I say that is in order to make that work, you're going to have to break your lines in weird places, because what you don't want to do is you don't want to break it like. Let me show you a really bad spot to break it. Like you wouldn't want to break it here. because that's a really weird spot to try to trace, right? It's like, oh, it's just a bunch of nameless connectors. You want to break it somewhere where there's a label that is going to be really easy to find again. For example, oh, this one says to system, which is a label that's on the connector. And I can say, oh, I'm going to pick that back up there with to system. It just makes it a little bit easier to make that jump. So I'd rather have the jumps make sense than to have all the line breaks line up on the same spot on the right. It's sort of a lesser of two evils scenario. So once you could then also insert your title block in here. You could scale this thing. Let me make this a little bit larger. Okay, maybe not that much. There we go. And then you could move it around inside your layout, put your title block in, and then plot it, and you'd have the whole thing. It would look like you did it in CAD. Everything would be super awesome, and I would be happy, and I would let you load in your show. Okay? So questions. Anybody got any questions about this? So let's take a look at the assignment. What is the assignment? So the assignment is for patch plot. I'm giving you that patch plot, okay, that I just showed you. Okay, so I'm giving it to you in, just an image file, and I want you to recreate that in Excel or Sheets. If Sheets makes you happy, that's fine, as long as you can still deliver it as a PDF. So you're going to recreate it, you're going to make it fit on an 11 by 17, and you're going to then insert it into a page layout in CAD with your title block and put it in there. Okay, just like this. Question comes in, is that borderline supposed to be that thick or should they all be the same? Yeah, oh, you mean like the borderline of just the insertion? So the best thing to do would be to stretch this, or to scale this so it fits within the border of your title block. There are some tricks you can do to make that border go away, and it involves like freezing, putting it on a special layer and then freezing that layer. I don't want to get into that right now. That's more complicated than I think we need to worry about at the moment. So I would just scale it so that the box fits inside of the border of your title block, and then we'll go from there. We'll see how that works. And I think maybe what you're looking at is that here in the page view, some of these look like they're a little thicker. It's just a rendering of the PDF. If you zoom in, you see it's not, right? So once you PDF it, it'll look right. Any other questions? All right, so this is your mission for the week, is make me this patch plot. Learn how to use Excel or Sheets or whatever you want to use. I would recommend Excel. That's what I demoed it on, but if you're happier with something else, that's fine. I don't really care, as long as it looks like this when you're done. Okay? So you've got a week to work on that. Let me know if you run into any problems. I'll be around. Lance tried to use my office hours thing the other day. I'm not sure why it didn't work. I was sitting there and he was sitting there and neither of us knew we were there. So I would just say, if you do want to use the office hours, maybe just drop me an email or a text or something. Say, hey, I want to talk to you, and then I'll figure out what's going on. Okay. But if that Monday, Wednesday, Friday, 3 to 4 doesn't work for you, just let me know. We'll find another time and I can chat with you. We can do a Zoom or a phone call or an email or something, and I can help you if you need help. Okay, let me stop the share. So last call for questions before I shut this thing down. Everyone good? We're ready? This is going to be awesome. All right. So this is an easy patch plot, by the way. I gave you a simple one for your first one. There's, the ones you will do later will be, much more complicated than this. So, you know, enjoy it while it lasts. All right, it'll get harder. All right, so I will see all of you later. I am doing another Sound Gym demo today. I'm going to do Peakmaster at 2 o'clock. If you'd like to get some tips on Peakmaster, join me at 2. I'll record it if you want to watch it afterwards. All right, I'll see you later. Have a good day.